differentiation of fractions using the quotient rule. So we have a function of x divided by another function of x, which we can simplify like this. So here's an example. So u is what you have in the numerator, e to the power of 3x, and v is what you see in the denominator, x squared. Again, in this example, u is equal to the numerator, so that's x, and v is 2x minus 1 in brackets to the power of a half. What you're not doing is this. So you're starting off with our fraction index form, and then if you bring out the denominator, so the power of a half changes sign to minus a half. You're not doing this. If you were to do this, you can still differentiate, but now you've got the product rule, because you've got the product of two functions of x. It's no longer a division. You don't have a fraction anymore. So use the product rule if you've done this. But this is unnecessary. If you see something in this form that's a fraction, which is a function of x divided by another function of x, stick to the quotient rule. And this is the quotient rule. The top part of the fraction looks quite similar to the product rule, which was this. You've got the v du by dx there. You've got the u dv by dx here. But you have a minus this time instead of the plus, and you're dividing by v squared. So if you set out your working out in a similar way to what we did for the product rule, so you put your function u here, you put v on this side, and then you differentiate. So we have du by dx, and here we have dv by dx here, and then we cross multiply this way to get that term, minus, and then we cross multiply this way to get this term, and the whole thing is over the denominator squared. Okay, so in this example, u is equal to x squared and v is equal to sine x, and then du by dx is equal to 2x, and dv by dx is equal to cos x. So we're going to get a fraction. So the order matters in this. So you cross multiply this way, so we have 2x sine x, and then there's a minus, and then you cross multiply this way, x squared cos x, and we divide by v squared. Now v is sine x, so if we square this we get sine squared x. Example 2. So we have a function of x divided by another function of x. Again, setting out the working out like this, u on the left, v on the right, differentiating each one, then cross multiplying in this direction first, and then in this direction there's always a minus over v squared. This is v, so v is 2x plus 5. We have to square that. There we go, 2x plus 5 squared. And we can simplify the numerator. So to work out the gradient for any point on this curve, so if we're looking at stationary points, tangents, normals, that kind of thing, we're going to use our derivative. Okay, so for stationary points we know the gradient is 0, so dy by dx is equal to 0, so we need to solve this equation. If I take the denominator and multiply it with a 0 on the other side, 0 times anything is 0. Factorize and solve. So these are the x coordinates for the two stationary points on the curve. If you're looking for the y coordinates, then use the equation of the curve. Example 3. So the function u is x plus e to the power of 2x, and the function v is ln x. That's exactly how we start. We differentiate each, and then again we cross multiply, and the order in which we cross multiply matters here. So we cross multiply in this direction first, and then in this direction, over v squared. Now this is the derivative. I'm using function notation. We can simplify. Sometimes we don't want a fraction within a fraction. So for something like this, we could multiply the numerator and denominator by x, like this. And x over x is equal to 1, so I've multiplied my derivative by 1, so I've not changed anything. So I'll get this. Then simplifying further, we get this, and be careful, in the numerator, this, the ln x in bracket squared, that is not the same as this. In here the x is only squared, and then we're doing the log of x squared, which you might think, well, you can write that as 2 ln x, which you can, but this is not the same as that, so I can't bring the 2 to the front. In this example, the denominator is a function of x, but the numerator is just a constant. So there is no necessity to use the quotient rule. It will still work, and I'll demonstrate that in part B. So for something like this, we can write that as y equals 5x to the power of minus 2, and then we just differentiate, and here's the final answer. And it's a very easy way to do things this way. Now in part B, we're going to use the quotient rule to do the same thing. You'll get the same final answer as before, but there's more working out to do this time, so it's not recommended that you do this. So u is 5v's x squared, differentiate. If you differentiate a constant, you get 0. Then again, cross multiply this way first, and then this way, over v squared, and then simplify, and then simplify again, and we have the same final answer, but with so much extra working out. So be careful. If you're going to use the quotient rule, you need a function of x here, and you need a function of x here in a fraction. For practice, try these questions. The ones in red are easier. You might want to skip them.